Got a question today that comes from the topic of binomial theorem. What we're asked to prove is this identity. Now, it's pretty tough to even start if you have no idea what any of the notation means. So let's begin first by laying down a few ground rules. Okay, what does it mean when you see this pair of brackets and two terms or expressions within that pair of brackets just sitting on top of each other? Looks like a fraction, but not really because it doesn't have the fraction line there. Well, that's our definition for, it's a shorthand for, really, n choose r, which is the typical binomial coefficient. Now, what does that mean? Well, it means two things. Number one, it's how many possible ways there are to choose or to arrange r elements if you've got n to choose from. So, for instance, if I wanted to make a team of 5 out of 10 people, the number of ways to do that would be 10 choose 5. Now, what does that mean? Well, that's shorthand again for n factorial on r factorial n minus r factorial. Got to be careful with those n's and r's. They do look alike. Okay. So you need to have that in mind because that's sort of our building block for how we're going to work with this thing. And lastly, we also need to remember, well, what does all this factorial business mean? Okay. Well, if you've got something like, say, n factorial, that's going to be n multiplied by n minus 1 multiplied by n minus 2 and so on, all the way until, well, depending on the size of n, you'll be multiplying by 3, then by 2, then by 1. You're kind of counting down, okay? So as an example, 4 factorial, that's 4 by 3 by 2 by 1, okay? So now that we know what this n choose r notation means, this binomial coefficient, and what the factorial notation means, we're going to use both of these pieces to actually solve this, okay? Now, how do you go about it? I think probably, generally, if you want to prove an identity like this, or like a trig identity, or those kinds of things, you want to take one side, the left-hand side or the right-hand side, and then work with it, simplify it, until you can get from that expression to this expression, or vice versa, okay? You can choose whichever way you like. However, just looking at this one, I would guess that we'd start from the right-hand side, because it's more complicated, and move to the left. The way we train our brains is kind of to make things simpler, rather than to make things more complicated. So it seems to make sense to go from 2 terms to 1 term. Now, you could go the other way, but I think it probably makes sense for us a little more. So I'm going to start from the right-hand side. So let's move this up a little bit. So I'm going to go right-hand side, and what it's equal to is n minus 1, choose r, plus n minus 1, choose r plus 1. Okay. Now, in order to work with this at all, what I want to do is bring it back to the definition for what does whatever choose whatever, what does it actually mean, okay? So if this is what n choose r means, what is n minus 1 choose r? Well, everywhere I saw an n factorial before, I'll have an n minus 1 factorial, okay? So I'm going to have on the numerator n minus 1 factorial on. Now, so far, that r is the same as before, okay? So I'll have an r factorial here. And then I'm going to have, here I had n minus r factorial, but I don't have n here, I've got n minus 1. So I'll have n minus 1 minus r factorial. Okay, so there's the first fraction, right? Let's do the second one. It's going to be n minus 1 factorial on the top again. Then, now instead of r factorial, I have r plus 1 factorial. Okay, and then, now you've got to be careful here, okay? Because before, we had just n and r. But now I've got n minus 1 and r plus 1. So you've got to be careful when you take the difference. It's easy to get it wrong. Okay, so what I'm going to do is put in some brackets here just to help myself out and make sure I don't mess up the negative signs. Okay, so I'll have n minus 1 minus r plus 1. Okay, and the brackets, and I think I've sort of run out of space there, so factorial. Okay, so that looks terrible. It looks a lot messier than what we start with, but often to simplify things, you've got to make them, things have to get worse before they get better, okay? So my question is, how do I get this to look anything like this, right? Well, immediately you can see I'm going to be combining two things, two fractions, into one. I should get one fraction at the end of this, right? So if I'm going to get two fractions into one, Usually my approach for that, regardless of whether I'm dealing with just, numbers or surds, irrational numbers, or, binomial coefficients and factorials, I'm going to have to get a common denominator, right? So how do I get a common denominator out of these? Well, before I do that, let's simplify this a bit. That looks a bit messy. I'm going to have n minus 1 factorial up here. That's still the same. I'm going to have an r factorial here. Now, even though it doesn't make that much difference, at least in the way it's written, I'm going to rearrange this. You'll see why in a couple of minutes. So I'm going to put that n minus r out in the middle. Okay, the r's in the middle rather than on the end. And then my other fraction, n minus 1 factorial, r plus 1 factorial. And what happens here? Well, I've got n minus 1 minus r, but that negative makes that a minus 1 on the end, okay? So this is going to be n minus r minus 2 factorial. Okay, now, how do I put these together? Let's sort of bring this aside for a minute. I'll pull this over here. Suppose you had something similar, but with actual numbers in it, okay? So suppose I was asking you to add something like this. Oh, I don't know, let's go like that. Okay, now if I asked you to put these on a common denominator, how would you go about it? You could, of course, work out what 4 factorial is. I think it's, it's 4 by 3 by 2, that's 24, okay? And 5 factorial, which is 120. And then you could just simplify as far down as you could, okay? And then just get it in terms of 2 common numbers. That would be fine, but obviously that approach wouldn't work if I had something like this. If I said, say, not 4 factorial, but 3 on 100 factorial, and 2 on 101 factorial. I mean, computationally, it's just ridiculous. What is 100 factorial? It's an enormous number, right? Which is, by the way, that's why the factorial is an exclamation mark, because the numbers just grow so fast, okay? So, being that I could reduce this to numbers, but it would be a bit dumb to do it here, how would I put something like this on a common denominator? Well, remember, what is the definition of a factorial? This 100 factorial is really shorthand for 100 times 99 times 98 times 97 and so on all the way to 1. So let me just sort of write that over here. That's 100 times 99 times 98 and so on all the way down to 1. What's that 101? Well, that's the same kind of thing, right? But with 101 as your starting point. All the way down to 1. And you can see when you look at these two, these numbers, even though they're huge numbers, they're almost the same. Like, all of these terms here are all over here, right? The only difference is that 101, okay? So what I could do is I could rewrite this. I could say, look, this is 3 on 100 factorial, but this is 2 on 101, that's the first number, times 100 factorial. Right? That's another way of writing 101 factorial. Now, this is a lot easier to work with, because now if I want these on a common denominator, the only thing I need to do is multiply the first fraction by 101. Right? So if I bring that down here, excuse me. Okay, so now that I've got that first fraction, these two now have the same denominator, namely 100 factorial. So this is 303, and that's 2, and they're both on 101 factorial, and then off you go, okay? So how can I use that property on what I'm working with at the moment, okay? Well, have a look at things like this. I've got an r factorial here, and I've got an r plus 1 factorial here. Now, if I want to get these two fractions to have the same denominator, what's the fastest way to do it? Well, in this case, what I did was I multiplied the smaller fraction, right? Oh, sorry, the denominator is smaller, but the fraction as a whole is start again. The denominator is smaller, the fraction as a whole is larger. Anyway, how do I get this to have the same denominator as that? I multiplied top and bottom by 101. That sort of bumped up the factorial from 100 factorial to 101 factorial, right? Well, have a look at this. How do I change these two, or which one do I change in order to have the same denominator? Well, if I multiply this fraction here by r plus 1 on the top and r plus 1 on the bottom. Okay, see what I'm doing there? Now, if I just think about this part here, that r plus 1 times r factorial, that is r plus 1 times r minus 1, and so on all the way down. That's r plus 1 factorial, right? So what I've got now, having adjusted the top and bottom, is I've got the numerator now matching, the denominator now matching between this fraction and, well, at least this part is fine, okay? Now, we're going to employ a very similar trick to work out how do I make this n minus r minus 1 and this n minus r minus 2, how am I going to get them to be equivalent? Well, which one is a bigger factorial? Which one starts with a bigger number? Well, n minus r minus 1 will be bigger than n minus r minus 2. Just like, say, 10 minus 1 is bigger than 10 minus 2. 9 is bigger than 8, okay? So therefore, what I need to do is I need to multiply this one by the next term along in the factorial. And the next term along is n minus r minus 1, okay? So if I chuck an n minus r minus 1 on the front there, okay, I also have an n minus 1 factorial, so don't ignore that. What's going to happen? Well, that r plus 1 factorial, we've already accounted for that. But this n minus r minus 2 factorial, now that it's got the next term along in the factorial sort of expansion, it's going to become this. So now I have the same denominators. This is excellent. Okay, right. So how do I put these together? Well, if the denominators are the same, then all I need to do is put together the numerators. So I have r plus 1 n minus 1 factorial, and then I've got n minus r minus 1 n minus 1 factorial all over this common denominator which I've determined. Right. Okay, still looks messy, but now that we've got them as one fraction, we've made a big step. Okay, we've made a lot of progress here. So how can we make this simpler? Because remember what I wanted to end up at. I wanted to end up at this, which is really, really simple. Okay, so on the top here, I notice I have this common factor, right? N minus 1 factorial. So I'll slap that out the front, and then what do I have multiplying that by? I've got r plus 1 there, right? And here I've got n minus r minus 1. Okay, and then there's my denominator. Now, look carefully at what I have on the right-hand side of the numerator here, okay? R plus 1, that's fine. But there's a minus r and a minus 1. So these terms are exactly going to cancel out. The r with the minus r and the 1 with the minus 1. So all I'm left with is n. Now, hold on a second. I've just been doing this kind of trick to adjust the denominators, right? I know what happens when you've got a number times a number minus 1 factorial. This is just the next step along in a factorial, right? So I can just write that as n factorial on r plus 1 factorial n minus r minus 1 factorial. Okay. Let me move that up a little bit so you can see it. Okay, so this looks pretty good. This is pretty simple, right? Is it simple enough? Well, let's have a look back at what we're trying to prove, right? What was I trying to get? This is the right-hand side. That's what I started with, right? I want to get it equal to the left-hand side. And choose r plus 1, okay? Now, what is n choose r plus 1? Well, based on this definition, right, it should be, if I have, instead of n choose r, if I have n choose r plus 1, that'll be a plus 1. This r will become r plus 1. And this n minus r factorial will become, the r plus 1 would become, would be in the brackets here. So it would become n minus r minus 1. The plus 1 becomes a negative because of that minus sign there, okay? So this would become n minus r minus 1 factorial. Now, have a look at what we've arrived at. I've got the n factorial on top. I've got the r plus 1 factorial over here, and that's the n minus r minus 1. Okay, if you wanted to make it super obvious, you could say, well, that's n factorial on r plus 1 factorial n minus r plus 1, just watch your brackets there. Okay, and that is, by definition, n choose r plus 1. That's the left-hand side. Okay, therefore, the identity is true. So that's it. That was the approach, okay? What we did was we took this, which looks a bit intimidating, and all we needed to really do was expand these binomial terms, okay? And be able to recognize, well, what do they really stand for, and how do we work with them to simplify it, okay?